There is no such thing as time, as defined in physics. It is a sensation like touch, taste, hearing, sight, and smell. Time is regarded as one of the fundamental quantities of physics. It is defined as the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the cesium-133 atom at 0 Kelvin. The others are length, mass, temperature, amount of substance, luminous intensity, and electric current. You can feel mass if you pick something up. You can feel hotness or coldness and be able to measure it. These are all real quantities in our world, but time is the only impostor, as its representation is within us and not in the world. So what exactly is time? Time is simply a measurement of change, using some another reference change. Our clocks are periodic and correspond to the reference change. So we interpret other things changing in our world with numbers on the clock. And we know that the seconds on the clock refer to the cesium atom, which is the clock's reference event. Every video we see is simply change being displayed on screen as the numbers increase periodically. This is an imaginative comparative arrangement that is not a physical quantity but a mental tool. So how do we feel time? Suppose we sit steady in a busy bus depot, and buses enter and leave, and so do the passengers. We can clearly feel time passing by. We know that so much is happening around us constantly our brain understands time is passing. But when we are asleep, we aren't conscious to gauge any change around us, and when we wake up we are not aware that 8 hours have passed by. We know 8 hours have passed when we look at the clock, which was a reference event constantly unfolding while we were asleep. Or maybe look at the sunlight that was not there when falling asleep. In short, the universe is constantly changing and there is no real past and future. It's more like a forever present tense that needs tracking. This can be explained with a time travel example. In popular fiction, there is a concept of time travel where one is able to travel to the past or the future. Anyone wanting to time travel does not really want the past or the future, but just wants the present changed, and feels that destination can simply be traveled to. But the universe is much more brutal in these matters. The only way to do that is to actually change the universe to get to the desired state. We can go back in the past if we could store the state of every atom and molecule in our body at that age, and then recreate it in the present with our current body. Theoretically, this would qualify as going to the past, but impossible to do in reality. But the future continues to be in our hand, as we can work towards it, and since we have no idea where it will go, all we can do in the universe is cause change. Alternatively, to travel into the distant future, it is more practical to freeze one's changes in the body, as other events in the universe keep happening. Imagine if one were to be preserved at 0 Kelvin temperature for millions of years, then that would count as a time travel forwarded to millions of years. While this is theoretical, this may be the only practical solution to space travel which has planetary bodies at a distance of millions of light years. Time dilation is basically having a different rate of change in one system as compared to the other. Temperature-induced time dilation is something that is not often discussed. In all of this, we see that tracking the changes in a system does not mean time is a fundamental quantity. Time is a sensation. It is along the lines of touch, taste, hearing, sight, and smell. Time is a sensation born out of memory. Higher organisms have better memory and thus have a better sense of time. This makes the difference between humans and a goldfish. So in the physical world, time is basically comparison of two simultaneous events. And in the world of the mind, time is a product of memory. Neither of these two conditions justify it to be a fundamental quantity of physics. The other fundamental quantities Do not share these weaknesses as they actually exist in the real world and are not imaginary tools. They are measurable and free from observer effects. Let us know your thoughts in the comments.